Hi everyone. Super excited for this one. So I'm Jeremy, I'm with SemiAnalysis. We're a market research firm specialized on tracking every part of the AI infrastructure stack. I'm really happy to be with two great partners and two great speakers. So guys, I'll let you introduce yourselves. Dan?
Okay, well, hello everyone. My name is Dan Chester. I lead the CSP business for Vast Data in Europe. Vast Data is a data platform and storage infrastructure provider. We help organizations that are training, deploying, and operating large-scale AI infrastructure at scale, in particular agentic workloads. The reason we're here and the relevance for this conversation is H uses Vast Data as the data platform along with the GPU cluster that they operate at Scaleway.
Hi, nice to meet you. So I'm Aurélien. So I'm leading the team, the model team at Edge Company. I'm also leading the initiative on reinforcement learning. We are using Scaleway and Vast solution to train our flash grip model. And I'm here to talk about agent because at Edge we are building computer use on VLM agent to run in the corporate world.
All right, awesome. So the goal of this panel is going to dig into agents and really understand what it actually is. And so a good way to get started perhaps is talk about potential use cases. So Aurélien, what do you think are the most typical enterprise pain points that can be automated with agents?
Yes, so we're working closely with company to build some customized solution. So one of the solutions we are building is a testing agent. It means that we are working with quality assurance team in company to help them to ship faster their software or their web application. So that's one of the use cases we are building. Another one is quite common, is to build some agentic workflow. So it means we are providing some computer use solution with hybrid solution with MCP in order to deliver some customized solution to orchestrate complex workflow, like to interact with legacy software, to interact with ERP, and sometimes to provide solution to an MCP. So it's quite a hybrid solution, and we are training a lot of models to do this.
Yeah. So Dan, you have a lot of enterprise relationships at Vast, so you have a really great view on what are the typical hurdles, or maybe what is perhaps underestimated when you talk about agent adoption within the enterprise?
Yeah, I think there are some concerns. Some are overblown, some are genuine in terms of enterprise adoption of agentic workloads. I think one of the biggest concerns that we hear from people is that you can't really deploy agents inside the traditional security perimeters that you would expect in terms of managing access to human users, let alone agents, in an enterprise context. So I think whilst that might have been true historically, it's a little bit overblown now. And I think that with the right consideration about data segregation, access controls, and auditability, it is possible to deploy agents in an enterprise workflow or an enterprise context. But one of the key things that you have to think about is how you manage access to data, how you audit that, and that requires a different way of thinking about the way that you manage your IT layer. So it's no longer just about having your classical IT systems. You also have potentially agentic workloads, and you need to think about managing completely for your human users and your agentic users within the enterprise context. I think the other thing that people were very concerned about were hallucinations, but behavior that is outside of the real-world parameter space. And one of the things that we've seen a lot more of is people getting involved in model grounding, and by connecting their AI models, and in this case, agents, to their enterprise data sets. And if you can ground your model to your enterprise data, it's much less likely you'll get a hallucination. I don't think that completely eliminates the requirement for human in the loop in some of the more critical workflows, but I think that model grounding is going to be one of the key things to making or to allowing more agentic autonomy within the enterprise.
Okay, super exciting. So Aurélien, you guys recently released a technical paper discussing one of your agents. So I would love if you could explain what are the building blocks in your agents. How did you build that agent and what does it do?
Yes, so most of our agents are based on a visual model. So it means that you can interact with a web browser, with a computer. So there are several components. We have the localizer. So with Holo 2, for example, we released on the Scaleway inference also. You have to build models that are able to understand the UI. So given us an interface on the web, any kind of UI, the model is able to reason, to do some reasoning, and to understand the UI, and to predict where to click at the specific localization. So it's the first component. It's quite cheap at the inference time. You have two other components. You have the judge and the policy. So the policy will be the model that will plan the action. So when you want to solve a complex task, you need to plan in advance what will be the next move. So we need to scale reinforcement learning to do this. So this is what we are trying to build. And it's quite complex. And you have also the judge. The judge will be a model that critique and will be like a guardrail of the agent, because he will critique the action of the agent and we'll try to make safe action, let's say. So we have three main components in the model, but we have also the agent logic. So it means you want to build some kind of wrapper that will orchestrate all of this. So this is what we release with Holo 2. We build some components to orchestrate all the model and to build safe agents that are able to navigate on the web, on the computer use.
And so, if we think about the training of these agents, like perhaps you can talk about to the extent that you can share how large is your training footprint to design these agents, and what are the most compute-intensive portions of the training?
Yes, so we train the policy, the judge, and the localizer at the same time. Let's say that we scale model from 3 billion parameters to 72 billion parameters. We are going to scale from with 200 to 300 billion parameters. So we are going to scale a lot, and even more in the future. So this is roughly the scale of the training. In terms of GPU, it's quite intensive also. It's a 1,000 GPU to train this kind of model. And yes, that's roughly the scaling we are using right now, and it's going to grow in the future.
And so, Dan, when we think about training and deploying these systems within enterprises, how can we make them compliant with enterprise strict requirements? How can we navigate through multiple clusters? What are the best ways to train that within an enterprise-grade layout?
So I think one of the things in an enterprise context is thinking about generalized versus custom models. And in order to deal with that properly, you've really got to deal with the idea of having a shared canonical data set, which represents potentially, well, in the context of H, perhaps one of their customers, or in the context of an enterprise, what the kind of the superset of data that exists within an organization. But then you need to think about per customer. And that on a per customer basis, you've got specific fine tuning, and you've also got specific memory associated with the agentic deployments. So all of that requires thinking about from a data platform perspective. In terms of respecting the customer data and IP, you've then got to think about proper secure isolation and effectively multi-tenancy. And then finally, audit and compliance. You've really got to log everything. If you think about the decisions that are being made and the consequences of some of those decisions, some of those could have particularly big impact, ranging, well, quite a big impact. So then there's a need for logging and auditing because that is going to become increasingly important, because you need to demonstrate not just what the decision was, but why the decision was, and you need to think about the model version, the data sets, and all of that becomes a metadata problem on top of the data problem as well.
And perhaps sovereignty? How do you think about sovereignty in the context of data for training these systems?
So I guess sovereignty exists at multiple levels. So you've got sovereignty in terms of how the model is built and deployed, so as H is training its models. Then there's the deployment piece. So I think that a lot of enterprises will be looking to deploy agents within the context or within the confines of their enterprise environment. So sovereignty is a function of where they allow those agents to operate. So are those agents operating inside their own data center on their existing data sets, or are those agents operating as a SaaS model in somebody else's cloud, in which case how does the data set that needs to be used get made available? So all of those things, again, just come back to data segregation, data access control, compliance, and logging, so that you can prove ultimately whether, if your goal was to be compliant, which it should be in most cases, especially under EU GDPR and EU AI Act, then you really do need to be able to keep a track of all of these things.
Aurélien, can you help us understand what is the cost to run an agent and how to think about the cost? What are different how do you break down that cost when running an agent within an enterprise?
Yes. So in the last technical report, we benchmark a lot the cost of agent because most of the time when you run an agent, you want to solve a task, and it takes multiple steps to solve the task. Sometimes for computer use, it can be 100 steps to solve the task. So it can be quite expensive if you use some, let's say, closed source AI. So we have published some benchmark with the OpenAI Anthropic model. And mostly for a difficult task, it can be from $1 to $10 for one task. So let's say if you want to automate some task in a company, it can be quite expensive. And with Holo 2, what we published, it's mostly the order of magnitude is 10 cents, let's say, for a task when we host the model and we do the inference on our side. So the order of magnitude is to 10 to 100 times cheaper than closed source model. So it's quite important also to build in partnership with the company the best agent and with the best model at the best price. If not, it will not be scalable in enterprise.
Do you see a lot of use cases where running these agents are cheaper or materially cheaper than humans, I guess?
Let's say it's the challenge of a forward deploy engineer to find the good use case at the right cost. In research, I'm not challenging on this part. Mainly, we are challenging on building the best model at the best cost, with the best performance, with a lot of speed. But in terms of cost, mostly this is why we have a team of FDE that is working in partnership with company, because you need to identify the good use case with the higher return on investment. We want to investigate in this kind of use case first.
Okay. And so if we think about the breakdown of that cost, like what are today the pain points? What are the most expensive parts when running these agents?
The policy mainly because you need to plan the action. It's quite easy because you have all the context in memory. So the agent will try to solve a computer use task. So you have all the memory of the previous actions that you have taken. So it can be a lot. The context can be from 16 to 32,000 tokens, and even more. So the policy is for sure the most expensive things to run. A localizer to understand the UI is quite cheap. It's a few milliseconds to run the inference. So yeah.
Okay. And Dan, what do you think are the main bottlenecks in your view when you think about hardware, software, perhaps model performance or system design? Where do you see the biggest bottlenecks in terms of cost?
So I think it's, as I've already said, agents are effectively consuming and producing data almost continuously in real time. And so one of the challenges is the time horizon over which agents are working and the complexity of tool use that they're going through becomes larger. That just massively increases, potentially orders of magnitude, the amount of data that's being generated and pushed around the organization. Effectively, that data layer becomes almost like an organizational memory. So that amount of data, the way that data is accessed becomes significantly higher. And then if you compare that to an infrastructure perspective, GPUs get faster. Of course, there's a nice cadence happening at the moment in terms of the updates, in terms of GPU performance, cost per token, and so on. Networking typically gets faster. Storage typically gets faster. So I don't think the challenge is necessarily in terms of the hardware itself, but I do think there is that challenge in data management within the organization. And so it's from an architecture perspective, it's about an enterprise data architecture which joins classical enterprise IT with the modern requirements of agentic AI and those agentic users. So not at the infrastructure layer, but at the data architecture layer, I would argue. You know, the infrastructure can keep up, but maybe the way that organizations manage data is going to be challenged by this.
Okay. And I think it's fascinating to talk about infrastructure because at VAST, you guys talk to enterprises, but also to all of the neoclouds. So you have a great view on what is happening in the world of infrastructure. So when you look at when you think about the future and what will the infrastructure require to deploy these agents will look like, what do you see, I guess, on both ends, on the enterprise side as well as on the neocloud or GPU as a service side?
So both the neocloud and enterprises need fast, consistent access to organizational data that data layer, that storage layer, needs to be co-located with the GPUs. The idea that when you train, for example, potentially you can train by moving a subset of data to your training environment, and then you can train, and then you can take that model. But once you're deploying a agent in production, then it needs real-time access to organizational data. It can't be dealing with batch process data that is being ETL'd out of ERP systems and so on. You need a system which is a single consistent view of the organizational data across the board. So the key point in all of that is the data needs to be adjacent to the GPUs, and that data needs to be consistent rather than, and in real time, rather than a separate copy that's being managed. That's what I described earlier as the agentic AI IT versus the enterprise IT. You really want commonality between the two. So that's where enterprises want to head. From the NeoCloud perspective, of course, they want to be able to drive the absolute best performance out of the GPUs that they have to maximize the return on that investment. I think that overall, what we'll see over time is that move to, rather than having a view of a fast local GPU storage layer and a slower enterprise tier, what we'll see is a convergence of those two, so you have both performance and scale across all data, so that you could therefore treat that as one organizational memory rather than some sort of long-term versus short-term memory. You've basically got everything at the fingertips of the agents and all of the processes within the business.
And earlier, obviously, currently we're seeing all of the major AI labs scaling their infrastructure dramatically to improve the capability of models. So I guess first question is, do you see many use cases that are bottlenecked by the current capabilities of models and agents?
So we're going to scale also to improve the performance of the model. We need to if we want to stay in the competition. So in 2026, we are going to scale all the number of tasks we want to solve. So it means we want agents that are able to understand any kind of software interface. So we want to deal with any kind of task on the computer use environment. So we'll have to scale reinforcement learning to scale the size of the model also. I don't know if we are going to scale to Anthropic or size or no, but we are going to do our best to do this. And yes, it's one of the main key things that we still need to solve. Yeah.
And if you think about the use cases that will be unlocked by this new scaling, like, are there a few things that you're particularly excited about?
So agent on device is quite exciting. There's a lot of traction around this, with small model running on mobile and are able to fulfill some autonomous tasks. So it's quite fun. On computer, we can still tackle some complex problem with complex interface. Like in the professional world, sometimes we are dealing with super complex interface. And we want to build some interface, some agents that are able to unlock some users to be better on the interface or to automate some work on this. So yes, definitely we want to tackle a lot of things on this and to unlock user.
And when you think about like where is the compute going to be located? We've seen some of the big American labs build massive data centers for inference. But in the enterprise world, there's a tradition of using on-premises data centers. So how do you think about where will the compute be deployed for these agentic use cases then?
So we're seeing some of the very large hedge funds, for example, the quant firms, building at a scale equivalent to some of the largest neoclouds, but they represent an exception. Most organizations don't have the existing data center estates that can support 150 plus kilowatts in a rack. So almost based on physical constraints, megawatts, footprint, data center capabilities, we are seeing enterprises forced to go outside of the traditional on-prem, or at least colo environments, to the neocloud. So that's obviously one of the reasons the neocloud market exists. I think that there'll probably be, as with most things, a reversion to the mean at some point in the future. Everybody hasn't all gone to the hyperscalers. We've seen some workloads go, some workloads come back. I think we'll see something similar, but I think most organizations recognize that they need capability with locality to their data. So the question is, do they move the data to the compute or the compute to the data? And in that lies a whole other topic, and I see we're pretty much over time. So,
All right, thanks so much.